Good day everyone, I'm NICOLLE P. ENRIQUEZ
Hi, my name is JUMARIE MOCON.
and we're going to discuss our research study entitled E-textile based fetal heart rate monitoring using Electret condenser microphone. Our advisors are Engineer Mayo Vincent C. Caya and Engineer Febus Reidj G. Cruz. Here's the overview of our presentation. First, we are to introduce our study, wherein we are to discuss the problem, our objectives for the study, its significance, and the scope and its limitations. Next is the methodology, followed by the discussion of our results, and lastly, our conclusion and recommendations for this study. Now, one of the first things that doctors can check for when a woman is determined to be pregnant is the fetus heart rate. A normal fetal heart rate ranges from 120 beats per minute to 160 beats per minute. Studies show that uncertainty in the fetus development may cause stress for pregnant women, which in turn may cause real-time effects on the fetus heart rate and development. To determine the fetal heart rate, hospitals use cardiotocograph, electrocardiogram, and other machines, but the most common of it all are ultrasound machines. Handheld devices like fetal Dopplers are usually used in small clinics. The inaccessibility of fetal monitoring devices at home have led pregnant women to monitor the fetal condition only when they come in for scheduled checkups at hospitals. These machines available at hospitals are not meant for pregnant women to be exposed to for a long period of time. Fetal Dopplers may be accessible at homes and are said to be safer for longer use, but it is advised by health professionals to use the said device with the surveillance of a healthcare personnel. From this, a portable wearable device that is capable of monitoring the fetal heart rate continuously using an Android mobile device has not yet been developed. Because of this, the researchers aim to develop a wearable prenatal support belt for a pregnant woman on their third trimester of pregnancy with a system that will allow the user to monitor the fetus heart rate. We specifically aim to first develop a system that could monitor, measure, and record the fetal heart rate using wavelet transform and fractal dimension algorithm. Second is to compare the fetal heart rate acquired by the developed device with the commercially available device, which is the fetal Doppler. And lastly is to develop an Android application which will display the acquired fetal heart rate and its corresponding status to determine if the acquired fetal heart rate is normal. The study will be beneficial for pregnant women on their third trimester of pregnancy for medical use in health centers in the future to aid in the determination of the fetal health status through the monitoring of the fetal heart rate. Now here are some of the scope and limitations of our study. The study covers the development of a wearable prenatal support belt to determine the fetal heart rate in beats per minute and its corresponding fetal status. The study does not concern the level of contraction of the woman's uterus as well as listening to the fetal heartbeat, as some medical devices cover such topic in relation with the study. The developed device was only tested exclusively on pregnant women on their third trimester of pregnancy because according to studies, the fetal heart rate is clearer in this time frame. The study is only based in the monitoring of the fetal heart rate of a single fetus on a woman's womb. The determination of the fetal heart rates of more than one fetal number of a woman on a woman's womb is not a scope of this study. The developed mobile device can only be used from Android 8.0 version up to the latest versions.
Hi, in the next following slides, I will be discussing the methodology, which includes conceptual framework, block diagram, actual device, warning mechanism and its validation, the system flowchart, and lastly, the mobile application interface. First off, the conceptual framework. This contains three parts: the input, the process, and the output. The input contains vibration of sound that was produced by the fetal heartbeat, wherein it will be translated by the electric microphone as electrical signals. Next, process. This contains the amplification and filtering of the signal that we produce in the Electret microphone. Since the signal is an analog, we could determine and extract the specific frequency that we only will be needing. And this signal will be converted to digital signal. Last is the output. This is where the computed values like graph, beats per minute, fetal heartbeat status, and log of data will be displayed. Now, we take a closer look at the hardware device. This black box contains different essential parts. First is the Electret microphone. This is an electrostatic capacitor-based microphone, which is usually used in phones, computers, and hands-free headset. It is then followed by LM7301 Low Power Rail-to-Rail Input-Output Operational Amplifier. This serves as the preamplifier for the very small signal produced by Electret microphone. LM8272 Dual RRIO. LM8272 is a rail-to-rail input and output op-amp, which can operate with a wide supply voltage range. Next is a 10K ohm precision trimmer. This will help us cut large signals that are not needed. Next is the LM8272 Dual RRIO, which serves as an amplifier before going to the microcontroller. Atmega 16U4 microcontroller is used for the calculation of time difference between repeating signals. HC05CSR Blue Core single chip Bluetooth serial port Bluetooth module is used as the mode of transportation of the produced data from hardware to the Android 8.0 mobile device. Here is the hardware device. The inner part contains two stethoscope heads. The purpose of this is to get the fetal heartbeat whatever the position of the fetal is. And the box is the one containing the circuit that processes the data. This is attached to a lightweight belly box support for pregnant women. Here we could see the system flowchart. We will be discussing on how the logic of the system works and how it operates. First, we will be starting with the connection of the hardware and the Android device. This is done by turning on the device and the Bluetooth of the Android device and selecting the hardware on the application. Next is to click the Start Recording. This will then start receiving the data from the hardware and display it to the screen. If we choose yes to continue recording, we will then process the data. This data is the received signal or sound vibration from the fetal heartbeat. This will then be converted to electrical signal as it goes to Electret microphone. Then, it goes to the preamplification. And to the first amplification, where we could easily determine the needed frequency. Since then, we could filter the signal by cutting unwanted frequency and signals that are unrelated to what we need. Then it goes to the second amplification before the microcontroller processes it. With the help of the Bluetooth module, the data from the microcontroller will be sent to the mobile device. Here is what the mobile device will do once the data is received. It will first display the signal in a graph, then record it on the text file as log. Now, depending on the value of the beats per minute, the display of the fetal heartbeat is displayed as follows. If the beats per minute is within 120 to 160, the BPM or beats per minute will be shown as normal, with the color of the text as green. If not, but in the range of 100 to 119, then it is displayed as warning, where the text would be in yellow. Otherwise, the beats per minute would be considered as danger, where the text would be red. After that, the date and time and value of BPM will be shown below the screen. Here shows the table for fetal heart rate guide. Less than 100 or greater than 160 is considered as abnormal. 100 to 119 is warning. 120 to 160 is considered as normal.
For the discussion of the results that we have acquired from testing of the two devices on 32 pregnant women on their third trimester of pregnancy, which is from 28th week to 36th week of gestation, the table shows that we have acquired an average percentage difference of 2.4375% between the results from the fetal Doppler and our E-textile device. We compared our acquired result to another study of a comparison of two commercially available devices, which is the fetal Doppler and the electrocardiogram. Based from that study, the average percentage difference of the two commercially available devices is 5.32%. It shows that we have acquired a lower average percentage difference compared to the said study, which could also mean that the device accuracy is good. To further validate the E-textile device, a correlation analysis is done. The correlation of coefficient R is used to measure how strong a relationship is between two variables. It returns a value ranges from -1 to +1. Based from the results that we have acquired, the correlation of coefficient of the data between the two devices is equal to 0.8907. This value is close to +1, which suggests that there is a strong positive correlation between the two devices, which is also reflected in the scatter plot shown. The set of points in the scatter plot lead to a positively correlated relationship. We have also acquired a linear regression equation. The equation shows a positive relationship between the two devices, which means that as the data from the fetal Doppler increases, the data that is gathered using the E-textile device also increases. For the conclusion of this study, the researchers were able to develop a fetal heart rate monitoring system for pregnant women on their third trimester of pregnancy using E-textile. The device was able to determine if the measured fetal heart rate is within the range of a normal fetal heart rate or not. Based from the results that we have acquired from the fetal Doppler and E-textile device on 32 pregnant women on their third trimester of pregnancy, the average percentage difference between the two is 2.4375%. The correlation of coefficient R acquired is 0.8907. These values that we have acquired suggest that there is a strong positive correlation between the two devices. For our recommendations, the researchers would like to have a customized accessory for the device. A smaller stethoscope bell used to amplify the fetal heart signal will be better for the comfort of the pregnant woman. Also, a pop-up notification for the fetal heart status is more convenient for pregnant women when using the application. It allows her to do other things while using the mobile device for fetal heart rate monitoring. So that ends our presentation. Thank you for listening.